Hello everyone. In this video, we will go through review questions for chapter 4, question number 1. Are these variables considered continuous or discrete? Recorded values of blood pressure, that will be within continuous ranges and intervals, that will be a continuous variable. IQ scores are also measured on a continuous scale, and that will be a continuous also. The amount of rainfall can be measured with precision, including fractional values. So it's a continuous variable. Stock prices also can be coded with high precision, including decimal points, depending on how precise we want our measurements to be. So it's a continuous variable. Number of customer transactions in a day is typically a countable quantity reported in whole numbers. So that's a discrete variable. Income levels are reported in discrete intervals for practical purposes. It can theoretically take any real value within a continuous range. So that will be a continuous variable. Question number 2. A fair coin is tossed 3 times. Let x be the number of heads that are observed. Construct probability of distribution of x. The fair coin is tossed 3 times. We will have a total of observations. 2 times 2 times 2, we have 8 observations. And we can write these all 8 observations as our sample space, including tail, 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 head, and tail, head, tail, or tail, head, and head, tail, tail, head, tail, head, 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 tail, or head, 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 which is 8 in total. To construct the probability of distribution of x, we have the outcome here and the probability of the x happen on the bottom row. So we can have 0 heads in 3 tosses, or 1 heads, or 2 heads, or 3 heads. The probability of 0 heads happen is just once over total 8. The probability that head happens once would be 3 times over total of 8 observations. Probability of 2 heads happen also will be 3 over 8. Probability of head happen 3 times would be also only once in 8 different observations. And also we can check if these numbers add up to 1, because the total of probability is 1. If we sum this up, we'll have 8 over 8 equals 1. Part B. Find the probability that at least 1 head is observed. Probability of at least 1 head is x greater equal 1. So we have probability of head happen 1 time plus probability of head happen 2 times plus probability of head happen 3 times. And we can simply add these probabilities all together. That would be 3 over 8 plus 3 over 8 plus 1 over 8 equals 7 over 8, or 0.875, which equals 87.5%. Question 3. Find the mean of discrete random variable x whose probability distribution is as follows. The mean of discrete, it means we can simply calculate the mu using this formula, sigma x px. We can simply multiply the events by the probability. Here we have minus 2 times 0.21 plus 1 times 0.34 plus 2 times 0.24 plus 3.5 times 0.21 here we will have minus 0.42 plus 0.34 plus 0.48 plus 735. If we add these up, we will have 1.135 as the mean or the expected value. Question 4. A service organization in a large town organizes a raffle each month. 1,000 raffle tickets are sold for $1 each. Each has an equal chance of winning. First prize is for 300, second prize is 200, and third prize is 100. Let X denote the net gain from purchase of one ticket. A. Construct a probability distribution of X. X is the outcome over the probability of X. Since it's asking for the net gain, if people paid 300, if the first winner is going to, the first prize is 300, the net gain would be $2.99 because they paid the ticket $1. And the second prize for 200, the net gain also same scenario. That will be also a net gain of $1.99. And the third prize of 100, the outcome of winning the third prize, the net gain for that third prize would be also $99. And the fourth outcome is winning nothing, which means being negative and paying $1. And the probability of these happen, it will be, since the total samples are 1,000, the probability of winning the first number is only 1 over 1,000. The probability of winning the second prize is only, again, 1 out of 1,000, because there's only one winning number per each of these prizes. And the third prize also would be 1 over 1,000. And the last one would be 1,000. So it would be 1,000 minus these three numbers would be 997 over 1,000. B. Find the probability of winning any money in the purchase of one ticket. Probability of winning any money would be the probability of first, second, and third prize. Probability of $2.99 plus probability of $1.99 plus probability of 99 equals 1,000th plus 1,000th plus 1,000th. It will be 3,000. C. Find the expected value of X. Expected value again would be sigma X, probability of X, for each of these outcomes. So that would be 299 times 1,000 plus 199 times 1,000 plus 99 times 1000 plus -1 times 997 thousandths. And if we add these numbers, we will have minus 0.4 and interpret its meaning. The negative value here means that one loses money on average. In particular, if someone were to buy ticket repeatedly, then although they would win now and then, on average they would lose 40 cents per ticket they purchased. Because we got the average value as a negative number. Question number 5. Suppose a friend told you that 10% of people in the population are left-handed. You randomly select 15 people from the population and count the number of left-handed people in the sample, denoted by X. Answer the following questions assuming people are either left or right-handed, but not both. Find the probability distribution of X. Since the outcomes are only either left or right-handed, it would be a binomial experiment. To write down all the outcomes of outcomes or X's by choosing 15 people, we will have 0. We can have 0 person to happen be left-handed, or 1% or 2%, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. We can have all these outcomes as to be success events and the probability of each of these outcomes. Since it's a binomial, we can calculate each of these outcomes using the binomial formula, where we can have n chose x p to the power of x times q to the power of n minus x. As a reminder, we know n equals the total number of trials. Here is 15. And x also would be number of success. Here would be number of left-handed people, and p would be probability of people in the population who are left-handed, and it's 10%, 0.1, and also q is 1 minus p, which is 0.9. So the probability of 0% to be left-handed, we can calculate as, I'm gonna erase this. Okay. If we plug in these numbers in the binomial formula, we will have 15 chose 0, probability of 0.1 to the power of 0 times q, which is 0.9 to the power of 15, and the total probability, if we plug these numbers in this formula, the total probability would be, I'm gonna put it here, 2058, and here we only write 4 decimals for entire probabilities, and if we plug in all these numbers and get the probability using same formula. We can have 15 choose 1 times probability of success to the power of x times q time to the power of 15 minus 1, it will be 14 here. I'm going to write down the final answers to the for up to 4 decimals. It will be the outcome of x equal 1 will be 34, 35, so this is 1. The outcome of x being 2, the probability of x equals 2 will be 0.2665. I already calculated these numbers and I just plug in the final answer. 1285, 0.0. This is for 3, this is for 4. I'm going to put 5 in here. 0.0104. For 6 we will have 0.0019. For 7, 0.0002. And after 8 people, we will only have 000 for the entire list. Like I said, I only put 4 decimals here. So this is a table of the probability distribution of x. Part B, how many left-handed people would you expect in a sample of 15 people? Number of how many left-handed people would you expect? It will be same as the expected value or the mean that we can obtain from this formula, sigma x times px. And we basically multiply the outcome by the probability. 0 times 0.2058 plus 1 times 0.3431 plus 2 times 0.2665 plus 3 times 0.1285 plus 4 times 0.0428 plus 5 times 0.0104 plus 6 times 0.0019 plus 7 times 0.0002. And the rest would be 0 plus 8 times 0.000 to 15 times 0.0000. And if we multiply these numbers and sum them up, we will get 1.4984 or almost 1.5 average people out of 15. Part C. What is the probability of getting 5 or more left-handed people in a sample of 15? Probability of getting 5 or more. Probability of x greater equal 5 would be all these numbers. Would be probability of getting 5, which is 0.0104 plus 0.019 plus 0.0002, and the rest are just zeros that I'm not gonna put them here. And equals, if we sum all this probability, which are probability of 5 plus probability of 6 plus probability of 7 people to the probability of having 15 people all left-handed. If we sum up these probabilities, we end up getting 0.0128 or 1.3%. What is the probability of getting 5 or more left-handed people in sample of 15? That will be about only 1.3%. 5 or more people of a sample of 15 will be left-handed. And part D, if the sample of 15 contains 5 left-handed people, would you suspect your friend may be wrong about 10% of people being left-handed? Based on the probability that only 10% of population can be left-handed, we obtain the probability of 5 or more out of 15 people happen to be left-handed as 1.3%, which is very, very rare, which is a very, very rare event, and only 1.3% of time we expect 5 or more people to be left-handed based on our assumption that 10% of population are left-handed as a result. So as a result, there's sufficient evidence to say that our friend is wrong, and there is more than 10% to be left-handed. Question 6. Discrete random variable x has the following probability distribution. Following histogram graphically illustrates the probability distribution as follows. Compute each of the following quantities. How can we get A? We know all these probabilities, they should sum to 1, and A would be basically 1 minus 0.2 plus 0.5 plus 0.1. Basically, A equals 0.2. B. Probability of 0, simply you can see from the table it's 0.5. Probability of x greater than 0, it will be probability of 1 plus probability of 4, which basically is, we got A as 0.2 plus 0.1 equals 0.3. Probability of x greater or equal than 0, it would be probability of 0 plus probability of 1 plus probability of 4. Basically, we just add 0.5 to the above answer plus 0.3 would be 0.8. Probability of x less equal minus 2. Since we don't have any value of minus 2 or even less, since we don't have any data for that, the probability would be 0. The mean or mu of x. We know we can calculate the mu using this formula. Mu is sigma x px. We can simply 1 plus 0 times 0.5 plus 1 times 0.2 plus 4 times 0.1. And if we add this up, we get the mu as 1.84. The variance sigma to the power sigma square of x. The variance or sigma square we can get from x minus mu square times px, and it's equal x minus, so we got 1.84 as the mu. No, I made a mistake, sorry. I think I was wrong when I was plugging these values. Let me calculate it. Minus 0.2 plus 0 plus 0.2 plus 0.4, it will be simply 0.4. So here we will have minus 1 minus mu square times the probability of minus 1, which is 0.2, plus 0 minus 0.4 square times the probability of 0, which is 0.5, plus 1 minus 0.4 square times the probability of 1, which is 0.2, plus 4 minus 0.4 squared times 0.1, and if we calculate these values, square them and add them, we'll get 1.84. The standard deviation sigma of x. Sigma is just basically a square root of sigma squared. It would be square root of 1.84 equals 1.3565. Thank you. Here we get to the end of the questions. We'll see you on next video.